what I'm going to try and prove here, I'm going to start with y equals u times v. So y is going to be some function, and u and v are going to be other functions. Okay. So if I'm doing a derivative from yesterday, okay, how did I do this thing right here? I'm going to pick actually on Christina here because you had to set up the last time. What do we do with the left-hand side for us? What does y change into?
Y turns into y plus d5.
Good.
And then on the other side,
Yeah, but I'm going to do u plus du and v plus du. Now, if you weren't here yesterday, which 3 of you weren't, okay, all that dy means is a very, very, very small change in y. Okay, so this is like pointing back to limits, right? Like you're approaching 0. It's going to be like 1 over a million or 1 over a billion is going to be what the change is. Okay, now when I look at this, I'm getting close, but I'm not quite there. Somebody suggest what I might do on the right-hand side to make this look better. Someone take a guess. Foil would probably be a good thing to try. So when I foil this out, I'm going to say y plus dy equals u times v plus u, whoops, plus u times dv plus v times du plus du dv. So what I just did there was I just foiled out everything. Thank you. It isn't. Michael, thank you for pointing that out anyway. And hopefully Michael can read that now even though he's not in the class, okay? That's his du and dv. Okay, if you have two things that are very, very small multiplied together, just like yesterday, what does that turn into? Nothing, okay? So I'm going to eliminate this from the question. Like 1 over a zillion times 1 over a zillion is almost nothing. So I'm going to say that y plus dy equals uv plus u du, so u dv plus v times du. All right, who wants to wave the magic wand at this point and fix this up? What do we do at this point? Not Michael, somebody else. Christina, go.
So we set y equal to
Y is equal to uv, lovely. Okay, so this is going to call this then uv plus dy equals uv plus u times dv plus v times du, which is going to be then dy. Okay, so we have dy equals now u dv plus v du. I'm going too fast. I'm going to slow down here. Yeah, go ahead.
Why did you just cross out du?
Okay, because you weren't here yesterday, but also because we said this is a good question here, though. Can someone explain this to him here rather than me? Somebody else. Why can I cross out du, dv?
It's a really, really ridiculously small variable.
Yeah, if you think, just think of it, if du is like a very, very small change, right?
Oh, multiplied by small numbers.
Yeah, like it's like 1 over a zillion times 1 over a zillion is like nothing all.
Yeah.
Okay, so I want to get dy by dx because we said dy by dx is a derivative, right? Guys, can talk here, please? Can I talk, please? I want to get dy by dx to get this as derivative, so I'm going to cheat. Okay? You want to see the cheat?
Yeah.
Cheating twice. Cheating twice. So this is going to be okay, so what I just did was I did bring a little extra thing in there. Guys, can I please do this? Okay. So I just divided everything by dx. That's all I did there. Okay. Now I want to do this proof because it's a lot easier than the other one. So the one involved limits and common factoring and stuff like that. Okay. But the idea is for that. So what I'm saying is, in order to get the derivative of a function of two things multiplied, you take the first thing and you multiply by the derivative of the second, and you add that to the second bracket times the derivative of the first one. Okay, so don't we write that in English?
Yes.
Okay. So in order to get the derivative of a product, yeah, ask place, right? Go ahead.
Why is the first one being
Because it's the derivative of the opposite one. So this is the original function times the derivative of the second. plus the second function times the derivative of the first. So the derivative of a product is the first bracket times the derivative of the second plus the second times the derivative of the first. Okay, and this allows us to do awesome things with derivatives very, very quickly. Okay, because again, we're just speeding things up. Okay, so if you now have anything that needs to be foiled, we can instantly take the derivative of it very, very fast. Okay, and we'll deal with this, why this is going to help us here in the next few days. Here. All right, example 1, then Michael's going to do example 2. Here we go. Are we ready? Too pumped up. You're going to hate me in this unit because you see that note that says Mr. Sanders slow down? Okay, that's what I'm feeling like today. My heart's racing. I'm so excited about these product rules. Wait till we get to chain rule. Oh my goodness, I'm going to be doing backflips. Okay, I won't. I can promise you that. Jeff, I will not.
I didn't even say 5.
That's asking a lot of that. Okay, here we go. Example 1 says, I will take you through example 1. I want you guys to try number 2. So it says use the product rule to find f prime of x. Okay, so I'm going to say f of x is equal to 6x plus 11 times x squared minus 3. Okay, so let's go through our definition here. Can somebody tell me, either read from the other page or do from your brain, how you find the derivative of something in brackets? No, goodness, never. We're going to avoid foiling, okay? Because I'm going to get to very soon things that are like 5 by 5, and that's going to be too big. What am I going to do here? Well, it's going to be the first function times the derivative of the second. So can somebody take the derivative of the second bracket for me? Is that good? Yeah, so f prime of x is going to be 6x plus 11 times 2x plus, what's the second half of the derivative going to be then? Yeah? 6 times x squared minus 3. Now let's just make sure we know how we got that. So this is u times dv. dv is going to be like the derivative of the second bracket, so x squared minus 3 changes to 2x, plus the derivative of the first bracket, which changes to 6, times the derivative of the second bracket is there. Okay, so you see what I tried to do there before? Okay. Now we got to flow it out. Okay, so we're saving ourselves a little time, so that's 12x squared plus 22x plus, what is that, 6x squared minus 18. So f prime of x equals 18x squared plus 22x minus 18. Okay, now I'm going to take a step back, and I'd like you guys to be brave here. Actually, just close your eyes for a change. Who understands what just happened on the board? Raise your hand. Knows everyone raise their hand. Okay. Okay. Get over your eyes. All right, example 2. Here we go. And I'm going to pause the video, and Michael's going to take this one up. Example 2. It's going to say f of x equals negative x cubed plus 8 times x plus 9. Okay, to foil that out, you could do it, but it's going to be a mess. I'm going to try and get in the habit of using the product rule, because after this example, we're doing bigger things than this. So I'm going to hit pause on the video. Michael will take up the solution, and I'm going to stop it.